The goal of this video is to teach you how to balance chemical equations, eventually with the goal of achieving this learning target, which is to balance chemical equations from their word equations, converting it to symbols, and then balancing. So how do we go about balancing chemical equations? Remember, the deal with chemical equations is that we have to consider the conservation of mass when we write down a chemical equation. Okay? What goes in comes out. Nothing is gained or lost. It's just transferred in that the bonds change. The way we go about balancing it out so that the same number of elements are there from start to finish is by adding coefficients, which are the numbers that are out in front of a chemical formula. We never try to balance by changing subscripts. We never try to balance by adding extra elements onto the start or the finish. Okay? Subscripts are something that we did when it came to naming. They all have to do with balancing charge. Coefficients are there then in order for us to make it the right number. So how do we go about balancing equations? I'm going to do this particular equation, which is also written on the board. And the way I like to think about balancing chemical equations is like a game. Okay? The rules of the game are that in the end, your number of reactant elements have to equal your number of product elements. In that, however many carbon you have on the left has to equal your carbon on the right. Okay? So it's a game. And once you have the numbers the same, you win. Game over. So I divide my equation in half. These are my reactants. These are my products. And down here is where I keep my score. Okay, my score is that I'm counting how many of each element I have so that I know when the game is over. Okay, I have to keep score to know when the game is over. Up here in the chemical equation is where I'm actually keeping track of the game, but down at the bottom is how I add up my score, essentially. So to start out with, what I do in this spot is I write down who the players are. I have carbon in my reaction, I have hydrogen in my reaction, and I have oxygen in my reaction. Those are my players. And if you're playing right, what elements you have in your reaction should be the same elements you have in your products. Okay, you can't all of a sudden introduce a new player once a game has begun. This is the beginning, basically. You can't introduce a new player once a game has begun. And now I count. This subscript tells me I have 2 carbons. I have 5 hydrogens here and 1 here for a total of 6. And then for oxygen, I have 1 here and I have 2 here. So I actually write that as 1 plus 2 so that as I manipulate my numbers, I remember that these 2 are different to get me a total of 3. Over here then, I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1 oxygens for a total of 3. And now the hardest thing about this method is it's really just like a guess and check situation in that you affect your equation and you see how it affects your score. I'll give you some hints in terms of how to more methodically do this after I show you how to, but a lot of this is just practice, more practice. So if I look at this, my first question is simply, what is not the same? And how could I make it the same? I'm going to start with my carbons. I have 2 carbons here and I only have 1 carbon on this side. I have to have 2 here for the game to be over. So here's my carbon. I only have 1 in the compound. So the question is, what coefficient can I put out front that if I multiply by the subscript on the element would give me the number I hope for? Since the subscript on carbon is 1, if I multiply that by a coefficient of 2, I'll have 2 carbons, which is what I want. Now the problem is carbon is bonded to oxygen, so if I increase my carbons by 2, I also affect this oxygen. If I multiply coefficient by subscript, 2 times 2, I now have 4 oxygens for a total of 5 on this side. So my carbons are good. Next I'm going to do my hydrogens. Okay, I have 6 on this side and only 2 over here. So the question is again, what coefficient can I put here that when multiplied by the subscript will get me the 6 that I want? And it's 3. If I go 3 times 2, I get my 6, which is what I hoped for. But since the hydrogen's bonded to water, I have to adjust this number also. 3 times 1 oxygen gave me a total of 3. 4 times 3 now means I have 7 oxygens. Carbon's good, hydrogen's good, oxygen is not good. I have 7 on the right, I need 7 on the left. And if I look at this with a total of 3, I'm like, man, 3 and 7, there's no good multiplier to get 3 to 7, right? 3 times 2 is 6, 3 times 3 is 9. Oh no. But if you look at your oxygens, you have 2 places where oxygen is. To get to 7, if somehow I can make this a 5, it would be 5 plus 2, and that would get me 7. Or if somehow I could make this a 6, it would be 6 plus 1, and that could get me a 7. So what I need to do is look back at my equation and see, can I make this a 5 or this a 6 easily to get me to 7? Now if I try to make this a 5, you should realize that by making this a 5, I'm going to affect my carbon and my hydrogen, thus unbalancing them. So I want to start out with the oxygen by themselves to see if I can just change oxygen and nothing else. Well, if I look up here, is there a coefficient I can add in front of the 2 to make this a 6? And it's a 3. Okay? So now if I make this into the 6, I have 7. And your game is over. Your game is over once all of your numbers are the same. Please notice a couple things. I always added whole numbers, meaning no fractions in front. Coefficients are always whole numbers. And the other thing to notice is the fact that a coefficient affects every element in the compound. You multiply the subscript by the coefficient. Okay, that's fine. That's the way it is, but every equation will balance if the equation is correct. So steps I went through when balancing my chemical equation are listed on your screen here. The correct formula written with reactants on one side and products on the other was already done for you. That's something we'll work on Monday and Tuesday. Then I counted up all of my atoms. Now, if there's a polyatomic ion, it's very helpful to count that as a thing. And I'll show you what I mean in a second. And then I basically just balanced. It was a guess and check. Okay? The only thing to remember is that by balancing, you're adding coefficients. You're never affecting subscripts, and you're never adding extra chemical formulas. And then the last thing you always want to do is make sure that in the process of balancing, you actually have the correct coefficients. If all the coefficients can be divided by like 2, you want to divide them down. So for example, if in this equation, instead of this ratio, you had gotten this, all of those numbers are divisible by 2, and so you should divide them to get the correct equation. So really, the art of balancing comes in with being able to determine where you start and in what order to balance. Because in all honesty, when I show you how to balance something after you have tried, some of you will say, oh my God, she made it look so easy. And that's because I start in the correct location. If you start somewhere that's not a great place to start, it can take a while. So where should you start? Number 1, try to do the most complex compound first. And by that I mean the one that has the most elements. So choose an element that's in the compound that has the most stuff, because that's the one that's going to affect most elements. Okay? And if you wait till the end and all of a sudden change the coefficient, you're changing all of your numbers. On that same kind of idea, save the simple ones to the end, meaning the ones that are by themselves. If you have like just iron, Fe, as a single element by itself in your chemical equation, don't balance iron till the very end. Or if you have any metal is the most common one to see by itself, or like a halogen by itself, wait for that element till the very end, because you know that you can balance it out by not affecting any other element. Keep your polyatomic ions together if they show up on the reactant side and on the product side. So for example, if you look at our equation we have, you see an OH group, which may lead you to be like, oh, it's hydroxide. But hydroxide isn't showing up on both sides of your chemical equations. If instead, on the reactant side, you had calcium sulfate, and on the product side, you had sodium sulfate, you would want to count this group as at 1 SO4 rather than 1 sulfur and 4 oxygens. Okay? That works the best. Now, if this had changed to SO3, then you would have to count them separately because it's not one entity that didn't actually undergo a chemical reaction. The other thing is, in terms of that single element, oxygen and hydrogen tend to be tricky because they show up in multiple locations. So it's not even that they're by themselves, but it's a really good idea to leave oxygen and hydrogen till the end of your balancing, balance them very last, because they show up in so many places. If you try to balance them, you find you have more than one compound coefficients you could adjust, and so you don't know which one to choose, and so it's easier to choose once you've balanced all the other elements. At this point, you can stop the video if you want to, and either work on like the first 10 practice problems for your worksheet, or do the 3 problems that are on the screen right now. What I'm going to do for the duration of the video is I'm going to work for these 3 equations using the counting method, okay, keeping score. Now just know I don't use that method when I do these problems on my own, and you don't have to either. I'm not going to check your work when it comes to balancing chemical equations. But the only way to guarantee that you get them right is to keep score, because then you can verify in the end that the count adds up to 0. So let's go. I have my players already written down. Zinc's a 1, hydrogen's a 1, chlorine's a 1, because there's an implied subscript of 1 on each of those elements. Zinc here is a 1, the hydrogen over here is 2, and the chlorine is a 2. So I told you guys one of the rules is to start with the compound that's the most complicated, and don't start with hydrogen. So if I look at this, ZnCl2 is the compound without hydrogen. And if I look, zinc is equal, but the chlorines are different. So I'm going to try to make the chlorines the same. I need a 2 here. So I look at the compound that has chlorine and I ask myself, what coefficient can I add in front of the compound so that if you multiply the coefficient by the subscript on chlorine, can I get 2? And since the subscript on chlorine is 1, I would put a 2 out front. Now it doesn't just affect chlorine because it's bonded to hydrogen, so I also end up with 2 hydrogens. If you look, that's a good thing because now all of them are equal and my game is over. Now be careful. Potentially with this equation, you look at this and you say, I need 2 chlorines, and you do something like this. You never add subscripts when you're balancing chemical equations. You can only add coefficients. Because remember, the subscripts are there to tell you what the chemical formula is, which is what you did last unit with charge, and you don't want to do it when you're just balancing. You can't change the ingredients, you can just change the proportion of the ingredients. You also can't place a coefficient in the middle of the compound. Okay, that's just wrong. You're messing with your chemical formula. You can never mess with your chemical formula. All you can do is add a number in front that tells you the relative proportions of how these things are reacting. Here we go with the next example. If you look at these, I have the players already, iron, chlorine, and now I have 2 polyatomics. And the reason I can count the polyatomics as a thing instead of counting like nitrogen and hydrogen separate is if you look at ammonium in the reactants and in the products, the chemical formula didn't change, meaning it didn't undergo a chemical reaction and I can count it as 1 unit. Same with hydroxide. It shows up in the reactants and the products, so it can be counted as 1 single thing. So 1 iron, 3 chlorines, 1 ammonium, 1 hydroxide, counting their subscripts. 1 iron, 3 hydroxides, 1 ammonium, 1 chlorine. So now if you look at this and you try to choose your most complicated chemical formula to start with, they all are pretty complicated. So the next thing I look at are unusual relationships, like if it's a 2 to 3 or a 1 to 3. Sometimes those 3s are a little harder to deal with than 2s. So if I look at this, we've got a 3 here that includes a polyatomic, so I guess I'll start with that. Irons are equal, but hydroxides are not. So over here I need to make 3 hydroxide. So again, the question is, what coefficient can I put in front of the compound? So if I multiply it by the subscript on hydroxide, I get 3. The subscript on hydroxide right now is 1. So if you put a 3 in front, you will get 3 hydroxides. You also affect your ammoniums because it's in the compound with hydroxide, and that's fine. The subscripts on the ammonium is 1. You have 1 ammonium. So 1 times 3 is 3. Now I check my equation again, and I see I'm still not balanced. Now, if you're smart, you can see quick that I'm not balanced with ammonium and chlorine ammonia and chlorine are in the same compound over here, so that's where I'm going. And I need to make both of them into a 3, which I can pretty easily do by a 3 coefficient. And then that one's balanced. So I've got my players listed. Again, I have a polyatomic that shows up on both sides, so I'm counting it as a whole. If I do my count, I have 1 of each based on subscripts on this side. Over here, I have 1 copper, 1 silver, but I have 2 nitrates. So the only thing here to start with is nitrate, because it's the only thing that's different. I need 2 over here. The subscript on nitrate is a 1, so I need 2 times that nitrate to get a 2. Now that affects my silver also, but if you look at this equation, affecting silver is no problem. Silver is alone on the other side, so to make it a 2, you just add the 2 subscript, and that's it. At this point, do more practice. Okay? Do the first 10 on your worksheet number 1. Have a nice night.